Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this YouTube channel, I'm covering the entire syllabus of IGCSE Cambridge Chemistry, and the course code is 0620. I also offer one-on-one tutoring lessons on my community with the name of High School Chemistry on school.com. So you can join that community for free. You can ask questions. You can participate in discussion forums in that community. You will get a free lesson per month, and if you need one-on-one lessons or group lessons, so there are different paid packages which you can choose from. And in that community I offer group lessons for four lessons per month, once per week, for just for $20, which is really economical. So the link is given below in the description. Okay, so in our previous lesson, which was 7.3 preparation of salts part 1, we discussed in detail that how to prepare salts from by using these different methods, an alkali by titration, B excess metal, C excess insoluble base, and excess insoluble carbonate. So now in this lesson, we will be looking at the solubility rules. So the second topic, it says that describe the general solubility rules for salts, like sodium, potassium, and ammonium. Salts are soluble. Yeah. So, these are sodium and potassium are group 1 elements, and they are positive ions, and along with ammonium. So no matter what they are connected to, no matter what the negative ion is connected with them, so they will always be soluble without any exception. So I've pasted this table here, which you can see that alkali metals, which are referring to, which refers to group 1, so lithium, sodium, potassium, rubidium, and cesium, all of them, they are soluble no matter what they are connected to. So similarly, ammonium ions, so ammonium is also a positive ion, so it is also soluble without any exception, right? So nitrates, bicarbonates, and chlorates, they are also soluble without any exception. And acetates are also soluble. And then, well, these are not included. Bicarbonates and chlorates, these are not included for IGCSE Cambridge 0620, and acetates as well. So you can ignore, but it is better to understand, or they must be on your list. So yeah, halides, they are generally soluble, but if they are connected with silver, like for example silver chloride, silver bromide, or silver iodide, then halides will be insoluble. Or apart from being connected to silver, if they are connected with mercury or lead, they will be insoluble. But again, silver fluoride, again, which is an exception, another exception, which is soluble, right? So sulfates, they are soluble, but if they are connected with these atoms, these ions, so then like silver sulfate will be insoluble, calcium, strontium sulfate, barium sulfate, mercury sulfate, lead sulfate, they will be insoluble. And now we take a look at the insoluble compounds. So carbonates, phosphates, and chromates. So chromate is again not included. So carbonates and phosphates, they are mostly insoluble, but again, we learned that group 1 elements or ammonium. So if carbonate or phosphate, they are connected to these, so like lithium, sodium, potassium, rubidium, cesium, or ammonium, then the carbonates and phosphates will be soluble, but other than that, these are insoluble. Most of the hydroxides are insoluble, and sulfides as well, but again we have some exceptions. So alkali metal compounds, like lithium, sodium, potassium, rubidium, cesium, and ammonium, so and those containing calcium, strontium, and barium, so these are soluble, but other than these, they will be insoluble, right? So now how you can memorize this, so I have included this information here. So the easiest way to memorize solubility rules is using mnemonic devices. Four mnemonics that cover most compounds are NAG, SAG, PMS, and Castro Bear. NAG and SAG are always soluble. Like for example, nitrates, acetates, and group one elements, right? And then SAG, sulfates, ammonium, and G, group 17. Not a very good mnemonic, but I'm you are Castor bear. Saying Castor bear makes it easier to distinguish between these metals and no water. Yeah. So I will merge this topic number 3 of the core syllabus for both core and extended students, supplement students with this one. So these are the two formulas you see. So copper sulfate, so CuSO4 dot 5H2O. So what is meant by this dot 5H2O? It means that 5 water molecules, they're chemically combined, right? They have made covalent bonds with copper sulfate, right? So and this salt is hydrated because it contains water. So what will happen when you heat it? So it will change into CuSO4 plus 5H2O. Remember that, okay? So now this form is called anhydrous, right? And this is hydrated. So this is hydrated. So that is the only difference between these two, right? So that is the only difference between these two. So now this is a hydrated salt that contains water where it is chemically combined, and this is anhydrous form where water is not connected with this, so it is called anhydrous. So I hope this is clear. So yeah, so this is what it is all about. Now question, like topic number 4, describe the preparation of insoluble salts by precipitation. Okay, this is the one that is the main topic that needs our like some extra attention, right? So this is the topic which students mostly don't understand, and they make lots of mistakes if questions are included from this topic, right? So now describe the preparation of insoluble salts by precipitation. So how do you prepare uh, you know an insoluble salt, right? So you need two beakers, and they will contain mixtures of soluble salts, right? So this is a soluble salt, and this is also a soluble salt, right? So when you mix them together, a double displacement reaction will occur, and you will get, an insoluble salt. A precipitation reaction will occur, right? So let me give you guys an example of a precipitation reaction, right? So that you can understand that how two soluble salts, they get mixed together and they create uh, a soluble salt, right? So yeah, so let's take a look at this. Let's say we have silver nitrate here, so Ag NO3. We have silver nitrate, right, which is soluble because nitrate, all nitrates are soluble. And in this one we can use silver sodium chloride, NaCl. So sodium chloride. So that is also a soluble salt. So remember that how do you prepare an insoluble salt by precipitation reaction by mixing two soluble salts together? So now you can either pour this beaker into this one or this beaker into this one. So now, let's see what type of reaction will occur, right? So it will be Ag NO3 plus sodium chloride. So, a double displacement reaction will occur, and we will get silver chloride, AgCl2, and it will be AgCl, right? Yeah. So silver is in +1 form. Okay, oxidation state, and the other one will be sodium nitrate, NaNO3. So from the solubility rules, which we just discussed, that if chlorides, halides are attached with silver, so they become insoluble, right? So as soon as you mix these two beakers together, these two solutions together, so you will see a precipitate, right? A precipitate of silver chloride, right? It will be precipitated at the bottom. So this is aqueous. It will remain dissolved. You will not be able to see it, and these two solutions, they will appear clear because the salts are already since the salts are soluble, so they will be dissolved, right? So this is called a double displacement reaction, where silver will join with chlorine or chloride ion, and sodium will combine with the nitrate ion, right? So this is how it works. And yeah, so now, so once you have this precipitate, now how do you separate it from this mixture? So we have this precipitate, which is basically an insoluble salt, which we just created by dissolving two soluble salts, right, by mixing two soluble salts together, and that's the chemical equation. So again, now we understand this, that you will filter this, right? So the salt, it is already like it is there, like it exists already, right, in a solid state. So you just need to filter it, right? And then you just need to wash it, and finally you need to dry it, right? So no need to heat or then allow to cool down. So in the previous lesson, when we were discussing this, the first topic, that how do we make uh, you know uh, uh, how do we make a soluble salt? So to retrieve that soluble salt from the beaker, we used to heat, and then we used to allow it to cool down. But here, no such step is required, because we already have the salt in the solid state. We just need to filter it, we need to wash it, and we need to dry it, right? So, and then, yeah, I hope this is clear. It will become even more clear when in the next lesson, we will take a look at the, you know, uh, the past paper questions, right? So you will understand that what type of questions they ask based on this topic. So yeah, and this time define the term water of crystallization. Yeah, so this water which you see connected to a salt, we have a special name for it. In hydrated salts, and the water part that is attached to the salt, that is called water of crystallization. So you just need to remember this term. The key word is define, right? So define the term water of crystallization as the water molecules present in hydrated crystals. Yeah. So these are the two examples. So we have 5 water molecules, which is called like water of crystallization, and we have cobalt chloride. So COCl2.6H2O. This is a hydrated salt, because you can see that water is chemically combined with this salt. So when you will heat it, so the water will evaporate, the mass will be decreased. There will be a decrease in the mass, and you will get 6 water molecules, right? So yeah, so this is now anhydrous. So I hope this is clear. And if you have any questions, you can leave them in the comment below. Like, subscribe, and share. And yeah, for one-on-one or group lessons, you can join my community, high school chemistry on school.com. So this will be all for today. and I will see you in the next one. Take care. Have a good day.